move right into it.
Okay, so for all positive values of x, what is the value of b? This is from Reddit. Can you link this, actually?
Yeah.
You don't have to do it quite yet. Actually, can you erase that and then we can be up here together because I miss you?
Sure.
No. Oh, yes.
Yeah, but I need to brag.
Oh, worry not.
You know I was leaving?
Worry not.
I'm not worrying.
And of the newborn? What of him?
Ah, the newborn is doing splendidly.
The little he with his head pulled back like a potato to see with his potato eyes.
I love that you've memorized that.
Yes.
From my poetry that I used to write in high school.
Yeah. Okay. So we need to figure out what b is. This guy is going to help us a lot. This function notation is definitely challenging. I'm going to use different colors to help us here. So basically, this is what all the basis of everything will be. That grammatically was horrifying. And this is the equation we're messing with. So f of 24x. Anything you ever have in here, you can just plug in for that x value there. So if this is, if you had f of 7, right, according to that first equation, you would get 7 to the b power, because you plug in 7 for x. But in this case, even though it's a little weird, we have 24x that we are plugging in for x. So we will get this guy equaling 24x, all of that raised to the 7th. It has to, or sorry, what am I saying? 7th was from something else to the b power.
Bzzz.
Similar, but not literally a b. I missed you so much.
I know. That's why I didn't want to say anything, because I knew that you would just say something like that.
Did you miss me?
I also missed you.
Very good.
Yes.
Was it fun?
It was great, yeah.
That's awesome.
My brother got married this past week, and I was the one who officiated the wedding.
That makes sense.
The chop makes sense.
Right, the chop makes sense. Okay, then this side, we're not messing with f of x at all. We know f of x equals x to the b. So the other side will be 3, because it's just 3 times f of x. So that would be 3 times x to the b power. And those two are equal to each other. You're probably not watching this live, so do you have any questions? No. Great. I'm glad you understand it. Now, let's move on from here. Now it's just solving a simple equation, maybe not so simple, but solving an equation to solve for b.
Yes.
Positive values of x. Interesting. Okay, so I'm going to distribute the b here to both of those terms.
Yep.
And I'll get 24 to the b power times x to the b power equals 3 times x to the b power.
Yay!
So now this is actually nice. I was worried because we have two variables. We have x and b. But actually now we can just totally cancel out both of the x to the b's. Technically what I just did there is dividing both sides of the equation by x to the b power. Now we just have 24 to the b power equals 3. You can do this on your calculator if you have it. That's about it.
Log.
Right? Or you can do the log. Well, regardless, yeah, you kind of have to do the log. So this would be the log base 24 of 3 equals b. So you just throw that guy in there and you'll get your answer.
What do you get?
You get...
It's less than half.
I have no idea.
I will do it. I will do it now. All right.
It's less than... Oh.
Yeah, there's a lot in there. Probably should have done that. Okay, log base 3 divided by log base 24. Okay, no. 3 log divided by 24 log equal to 0.3456, then 8. 0.3456.
That was the worst way to say that.
I just kept going up.
0.3456.
And then 8, which we want 7, but it's 8.
Sad.
Sad.
So that is what b is roughly.
Very rough.
Yes. Be rough.
Bzzz. Ow! That was rough.
That was rough.
It was.
Okay. That's great. Let's... I'll post that on Reddit. You want to do something else?
Yeah!
Here, let me see if I can find you something juicy. on Reddit here.
Yeah, find me something good.
Oh, here's another juicy one.
Can we not do that one? I have to do something similar to it.
Okay, so you're probably going to have to make up your own here, Bird. If you search that, that's what you get. Awesome. It's pretty awesome.
Let me send this to him, just so he knows.
Okay. Okay, I'm going to erase this. We'll get that next one up. I don't know who this Reddit person was, but we will do this.
Is his phone down here?
Yeah, he's down here.
Oh, you're upstairs. Okay, see what I missed? See what I sent you?
Oh my gosh!
Oh, look at that.
That's why you should not have said.
Oh, I see. I feel like you should have picked up on sarcasm too. Got it.
Mr. Knight will be back soon, but Mr. Knight cannot help you very much, Usway, because you're a junior. Unless you plan on going to college next year.
Well done to the Jay the Whiz Kid. 3 months in a row. Well done.
Dude, your lungs were very prepared for that.
I know.
You were well rested. Thank you for the subs, Jay. Do you have questions? How you doing? I feel like I haven't seen anybody in a long time.
So we do
It
it.
has been a long weekend.
Yes.
I just possibly got another student for Sundays.
I heard back from Mongolia.
Good things?
Yeah.
Just the one?
Yeah.
Okay, cool.
Yeah.
When's that starting up?
We'll see. Scheduling
Cool.
is
Oh, good. So that might actually
happen.
happen.
Looks like it. Yeah,
Okay.
It'll be fun.
Jay, you got some questions for us? Do you want to do this guy?
Yeah.
Come up with some stuff here?
Absolutely. So I have to make it my own.
Yes. Make it yours.
I can do that. Okay, so we have a triangle situation here, which just means there's a triangle. That's what a triangle situation is, if you ever hear that phrase. And we have, okay, let's see what we have here. J, K, L, M, and then we have X and X here, and it says, okay, so the area of triangle, let's see, JKL is 2x squared. Great. It's asking for the cosine of angle B, okay, so that would be KLM. Good. Actually, no, it's something else. This is meant to be 10x squared. What is the cosine of angle KLM? Okay, KLM, we're going to find that. We're going to need a couple of things. We are going to need some side lengths, things like that. So, JKL, the entire triangle is 10x squared. So the area of a triangle, as we all should know at this point, is 1/2 base times height. We have the height, that is x. What we do not have is the entire base. We have part of the base. The rest of this, I'm going to call this y. So this whole thing, if the area we know is 10x squared, I'm going to write that right here. And then our actual formula, 1/2 base times height, would be 1/2, our base is x plus y, and our height is x. So if I multiply these things out, we're going to have, okay, base times height. So it's going to be 1/2 x squared plus 1/2 xy. Very good. Okay, and those things are equivalent. So if we want to solve this thing for x, there's a couple of things we can do. The first thing is everything has an x in it, so we can divide the entire thing by x. So I'm going to go ahead and just do that. By dividing by x, you have to remember that you are getting rid of the possibility that x equals 0. That's like one of the solutions here. Because 0 is equal to 0 plus 0 would work. The problem is we are talking about something in the real world that can't just have a length of 0, otherwise it wouldn't exist. So we just have to, sometimes, for polynomials, that's something you have to keep in mind, is that when you divide everything by a variable, you're getting rid of the possibility that the variable is equal to 0. So what we have now is 10x is equal to 1/2 x plus 1/2 y. Because we got to. So if I combine these things, I'm going to subtract 1/2 x. I'm going to put the x's together, and the y is just going to be off on its own. So we have 9.5x is equal to 1/2 y. And what that means I can do here is I can solve for y in terms of x and put that in for y. So I can have the entire base as x, and then we can actually start seeing some things happen. So if I want to solve this thing for y, I would multiply both sides by 2, because that would be the same thing as dividing by 0.5. So multiply both sides by 2, and you're going to get 19x is equal to y. So in for y, I'm not going to write 19x. What that means is, if we do our area formula one more time, we're going to be able to solve for x itself. So we have, the base is 19x plus x, which is 20x. So we have 1/2, the base is 20x, the height is just x, and that's equal to our area, 10x squared. So 1/2 x, oh, is that going to help at all? Oh, okay. In fact, this is actually not going to do anything for us, because if you see, this is going to turn into 10x squared equals 10x squared. So we can't actually solve for x, but we don't need to be able to do that to find the cosine. All right, back to our triangle. We're finding the cosine of KLM, which is this angle here. Cosine is adjacent over hypotenuse. We have the adjacent here. By the way, we're only looking at this right triangle here. We're not looking at the whole thing. If you want to find sines, cosines, and tangents, you better find a right triangle to find them on, because other triangles you can't actually create the ratio by looking at the side lengths. So adjacent is 19x. What we don't have is the hypotenuse. We can solve for the hypotenuse in terms of x because we have the legs of the triangle. We're going to just have to do that. Okay? So to find the hypotenuse, we're just going to do Pythagorean Theorem, which is kind of the name of the game called Pythagorean Theorem. I don't know if you ever played it. It involves you doing Pythagorean Theorem. And the name of the game is Pythagorean Theorem. Our a squared is going to be one side x squared plus 19x squared is equal to c squared. Levi, 19 squared.
Yes.
What is that, 389?
Let's see, 20 times 20 is
381.
400, so 19 times 20 would be 380 minus another 19, so 361.
Okay, nice. X squared plus 361 x squared is equal to c squared. This is going to be 362 x squared is equal to c squared. So our c value is going to be the square root of 362 x squared, which is going to be x times the square root of 362, which we could probably simplify. But for right now, I'm just going to leave it like that. So this is going to be x times the square root of 362. And now we can finally take the cosine. The cosine is adjacent over the hypotenuse. That's going to be 19x over x square root of 362. The x's are going to cancel out, leaving us with 19 over the square root of 362. Chances are they're going to want you to rationalize that, so you want to get the square root out of the denominator. Hey, Boss Dad. Levi, do you know Boss Dad?
Yeah, Boss Dad was here last week.
Good. 19 divided by 362. Is that 19 times 19 and 361? Okay, which unfortunately you can't really do a lot with. You multiply the top and bottom by the radical in the denominator. and you're going to get 19 root 361 over, oh, sorry, that's 362. Sorry. Boss Dad, if you saw that coming, you didn't say anything, you're dead to me. Over over just 362. And there's no way to simplify that, unfortunately. Okay. Hi, ASDF man with a plan. You have a question after this. Is that your question? Just the question mark? What is your question? You must tell us your question, because I am now done with this. Okay. Wait. Oh, okay. So yeah. So what is your question? It's about factoring by grouping? Yeah, we love that stuff.
Yes.
We love that stuff.
I do like factoring by grouping.
You didn't used to.
Really?
I don't know.
I had to teach synthetic division.
You had to teach it?
Yeah.
How'd it go?
It was fine. It's just boring. He's like, oh, can I use it in this situation? I was like, no. And he was like, can I use it in this situation? I was like, no.
Well, then why are you teaching him that?
Because... Ooh, that's fun. Yeah, let's do it.
Oh,
Is this your homework?
He's got his math exam next week. Oh, that's Boss Dad. Boss Dad, you got your math exam next week. That's huge, man. Are you excited? Levi's going to handle this one.
So huge. Is this going to work okay? Is it going to work? Let me see it.
Take a 4 out. 5 plus 4.
I don't know if that's particularly factorable.
I don't think it's factorable.
Yeah.
Yeah, x plus 8.
Yeah,
it
shouldn't work.
Are you sure it's not plus 2x plus 16?
Yeah.
That's the typo. It should be plus 2x plus 16, because that would be factorable.
Yeah.
So Levi's just going to treat it like it's that.
Yeah, let us know if it's not, but I'll start with that. Because that 20...
is impossible. Yeah, which test prep book is this?
Or is this your textbook?
Did you make this test prep book and then you're wondering why it's not working?
That's good. Run it by us. We do this all the time. We're test prep
Summit
book
Educational.
editors.
Oh, you know what? Summit Educational has a history of writing 20x when they should have written. They should have written.
It's a
2x.
silent 0, if you will.
Yes.
Yeah.
That looks tasty. Go get him.
It's like a dog.
Yeah. So there are typos. Everything has typos. Nobody's perfect. Everyone's flawed.
Humanity was a typo, I heard.
Really?
Yeah. Oh, did I tell you that I would kill you next time you pissed me off?
No.
Okay.
But is that starting now or the one?
No, it's starting before. You're gonna get killed by your business partner.
Got it. Which is you?
No. Mm-hmm.
Right. That was a cool dance.
Thank you.
Oh, should we do it again?
I know. My hip hurts.
Just a handshake.
My hip hurts.
Just a handshake. And then you flip it up here, and then you just sort of do a little spin.
Imagine you saw the spin.
Jeez.
No, my hip does actually hurt.
Wait, are you gonna factor this for one?
Well, it's gone.
2 spins. Yeah, you gonna keep the crowd wanting 2 spins?
No.
Not gonna satisfy?
No.
Can you finish
What
this?
is it? I don't remember what it was.
Plus 8x squared plus 2x plus 16.
This is factorable. If you...
He's right. Go slow with your hip.
Okay, I'll go slow with my hip. I'm not gonna go slow with my hip.
Just go really slow with your hip.
Oh, I didn't think of it that way.
That's the opposite. They wanted 2 spins. All right. Do you want us to factor that, or do you know how to do that? I mean, you can do it quickly.
Watch.
Alright, I got a jar of peanut butter. No. Yes. Absolutely not. Because.
Bam.
Very good, Levi. So wait, you were gonna say something to me before, though.
Oh yes.
Did you tell me that what? I spun you the first time.
Oh yes. It was about ballet. I was thinking of a ballet dance with beautiful ballet dancers, but instead of like the flowy little ballet finger thing that they do, it's just middle fingers. Just the whole time they're just flipping everybody off. I think it's nice.
This is just a situation you thought of?
Yes.
It'd be truly absurd.
Yeah.
Yeah, I think you're onto something.
Yeah.
Do you think it's happening somewhere right now?
Yes.
Levi is good at blowing minds.
Yep.
Yeah, of course. Take another question with us. I wonder, can you blow your own mind?
Oh yeah. People do it all the time. Yeah.
What was the question? Okay, I have
do more stuff.
5 equations, and one of them has only one root. It's either this is fundamental theorem of algebra. Well, no, I mean the peanut butter in the jar, not the jar itself. I got this one. It's gonna be sick. Where did my markers go?
I don't know here in algebra.
That's how you said it.
Yeah.
Yes. Stop.
I didn't know. Didn't know you would like that. Oh no. Oh.
It's going to be the last one. No, it's not. You miswrote one of those. Are you sure the first one is an x minus 1?
The first one is x minus 1. X
No.
squared minus 1.
Right. Okay. So what you're thinking of here is what Levi wrote horribly, the fundamental theorem of algebra. And it has to do with polynomials and the roots that they have. So a polynomial of degree n. What time is it where you lads are? Time for polynomials. We live in New York, so Eastern Standard Time. It's what is it, around 8 something?
8:07.
Got it. Polynomial of degree n has n roots. Oh my god, this is a terrible marker. So degree means the exponent, the highest exponent that you see in the equation.
Has it most n roots, right?
Well, there's real and imaginary. It's going to have n roots.
Yes, of course.
Here's where it gets tricky, okay? Roots are the word root does not imply real or imaginary. Overall, it's okay. We gotta.
Stop.
Oh, it's coming out now.
Dude.
This is great.
Dude, that makes more noise than it writes.
We've never. You're right. Okay. That's the biggest joke I've ever had with the pleasure of hearing. What joke was I just make a joke? Probably. The roots could be real or imaginary. So really complex. So you might see some of them on, remember roots being x-intercepts. That's what they look like when they're real, okay? But you might have complex roots that you wouldn't see. Overall, though, you need to have n roots. Every cubic will have 3 roots. They might not all be real. It need to be at least one real, because if you have a cubic, it goes across a graph, so it's got to cross the x-axis at one time. My barber says I have complex roots. Very good. Hey, we should hire him or her for Nerdish.
Who is that?
I don't know. Ostman with a plan. So, Ostman, in order to have only one root, you need to have a linear factor. Sorry, a linear. Like x plus 3, or sorry, that's 2. Or 3x minus 5. It needs to have a degree of 1 to have only one root. What I'm wondering is when they say just one root, they might mean one distinct root, because everything you gave us, so like x squared minus 1. If you solve this thing, you set it equal to 0, that's how you find roots. You know, it's where the y is 0. x squared, that's an alpha, sorry. X squared is equal to 1. X is equal to the square root of 1, which is plus or minus 1. All right? That's two different roots. If you have x squared plus 1, and you solve that by setting it equal to 0, you know, I always say we got to go through all these markers and figure out what's going on, and we just never do. X squared is
only matters for you.
-1. I know, but I say that we need to do that. Take the square root of both. You're going to get x is equal to plus or minus I, okay? Which are two roots.
Why not 3, my lord?
Very good. So then you've got a bunch of cubics, and they are all going to have 3 roots. What I'm guessing the question is which one has one real root? One distinct real root. So you only see it cross the x-axis at one place. This one here will cross, let's see, x squared minus 1. It's going to cross at 1 and -1. It's going to look like that. This one here is never going to cross the x-axis because it is above the x-axis. So if you had a complex plane coordinate system, you would see the x-intercepts. You'd have to make it three-dimensional and colors and all sorts of stuff because it's hard to make that visible. But either way, this has 2 roots. It has no actual, okay. Only one root. Yeah, so, okay. Okay, here's what they're missing. Distinct root. They're missing distinct root. If you have the polynomial x plus 2 squared is equal to 0, which is a quadratic of degree 2, you have -2, -2. Your roots are the same. So there's only one distinct root here, but there are still 2 roots, but they just happen to be the same thing. I believe that is what they're asking, is which one has only one distinct root. Because it's going to have the number of roots that matches the degree. So the ones we've talked about so far have 2 different roots, so we have to go to the other ones. One of them is going to be a perfect cube. That's what's going to happen here. If we factor the first one, this is useless, just taking up space. That's what they used to say about me before I proved my use and stops taking up space. The first one is x cubed minus x squared plus x minus 1. All right, if we factor this by grouping, we're going to have x squared times x minus 1 plus x minus 1, which is going to be a 1 here. So that's going to be x squared plus 1 times x minus 1. You're going to get 3 roots here. Going to be a positive 1, then you get a plus or minus I. So that's got 3 roots. I think you're right, though. That makes sense. Based on the other stuff that Stephen Hawking was a fraud. Stephen Hawking was a fraud? No, not that I know of. Bostad, you have to give us some evidence of that. Got to give us some evidence. All right, this has 1 real root, but there are still 3 roots here. You got 1, you got plus or minus I. We're going to get a perfect cube. That is going to have only 1 distinct root. That is what I am predicting is what the answer is going to be. Have you factored the other ones yet? Did you get one that's just a perfect cube? Stephen Hawking was a fraud, but Stephen Hawking was a hawk. All right, great. So, oh, that's AFD man. Okay, I was going to say, is that Bostad's evidence? Because that's pretty weak evidence. But no, that's just ASDF man with a plan, throwing some stuff on there. Okay, one sec. So I no longer can see the second to last one, but I can see the last one. X cubed minus 3x squared plus 3x minus 1. So this is going to be x squared, x minus 3 plus, that's not going to be factorable. Okay, so that last one is not factorable. So the second to last one, I'm going to put, you know what, I have to scroll up to see that one. That's what it is. And that one is also not going to be factorable. Doesn't mean there's not a root, though. Minus 2x squared plus 2x minus 1. X minus 2. Yeah, that's also not factorable. Interesting. Stephen Hawking made the theory of relativity. You're thinking of Einstein? Well, I don't believe it, so therefore I legally and factually wrong. So I don't believe it, so therefore I legally and factually wrong.
That's what I think. What do you think, Bert?
The book says the answer is the last one. The last one that I just factored, which is not factorable. X cubed minus 3x squared plus 3x minus 1. I mean, just because it's not factorable doesn't mean there's not roots. With the 3's. Yeah. You would have to... Do you get a graphing calculator for this? I mean, if this is SAT prep... if this is ACT prep, you get a calculator. If this is the calc section for the SAT, you get a calculator. What is this supposed to be for? Because if you get a graphing calculator, everything we're talking about, ACT, okay, you get a graphing calculator. So you got two things here. You can go to the polynomial root solver, which is part of your, if you have a TI 83 or 84 or 84 plus or 84 plus CE or a TI Inspire, then you can go to the polynomial root solver and it will just do it for you, or you can graph it. You can graph it and you can see where it crosses the x-axis. Now still, if you have a cubic, you could have 3 roots that are all real, or you could have 1 real root and 2 complex roots. And those 2 complex roots are going to be complex conjugates of each other. So just to give you some context here, whenever you have complex roots come in this form, a plus bi. They are a real number plus an imaginary number. All right? So we have real, imaginary. If you have both of them together, you have a complex root. They will always come in pairs if they are a root. So 4 plus 3i will be an answer, and so will 4 minus 3i. Therefore, you're always going to have an even number of complex roots. You can't just have one complex root. If you got one, you have the one that's the opposite with the minus instead of the plus. So if you have 3 roots, you could either have 3 real, or you could have 1 real, and 2, and 2 complex. So either way, what you'd have to have here is for there to be only 1 root. They're either saying 1 real root, or they're saying 1 distinct real root. And you'd have to factor, you'd have to put this in your calculator. So ACF on the plan, what kind of calculator do you have? $84. Good. Okay. Here's what you're going to do. You got it in front of you? If you do, say yes. And I'm going to start giving you instructions. But it's dead. Got it. Okay. So is my great-great-grandfather. Okay. Well, you know, we're always here. So, like, if you can plug it into charge right now, but I have Wolfram Alpha. Sure. I mean, it's not... I mean, no, it's a great resource, but you don't have that on the ACT. You have your calculator. So I want to show you how to do it with your calculator. That's what you want to do here. Can you, geez. Calculators. How is x minus 3? That would work. That's 3. Sorry I let you down. No, you didn't let me down. You let yourself down. And that's what's really important at the end of the day. Which, coincidentally, it's becoming... You don't have batteries either. Oh, so that's why you're... Oh, okay. I was going to say, that's why your calculator's dead, because there's no batteries. But I realized you don't have new, fresh batteries. Did I let Levi down? Levi.
Yep.
Yeah, Levi says yes. So
wait, what?
Did he or she let you down with not having a fresh calculator?
Yeah.
Yeah?
Yep.
So Levi says yes. So you did not let me down, but you let yourself down and you let Levi down. That's 2 out of 3, which is a majority, which means yes, you let down. More so than you did not let down. What I was going to say is there's a part of your calculator called apps, which is short for applications. You press the button that says apps. It brings up a couple of things. One of them should be polysmelt, which is PLYSMLT. It finds you polynomial roots. So you click that, it opens up a little file that lets you say, hey, I've got a cubic, so degree 3, here's the A, B, C, and D, solve it for me, and it will give you the roots, which is pretty nice. Fun fact, the founder of Casio calculators, Tadao Casio, called it Casio after winning 5 Vietnamese dong by using this calculator to work out the probability of him winning. He took out the N in casino and called it Casio. Oh, that is kind of fun. Bosted, did you make that up? It sounds like it'd be real. but those are the best things to make up because then people believe you. I have a dad that does that a lot. I don't know what I'm waiting for. Levi.
Yep.
What do you got?
Posting on Reddit and stuff.
Do we put a story on Instagram?
No.
You want to do that? Why not? It's fun.
Okay, let me just finish this post.
Still got 40 minutes. Oh, what is he doing? What a goofball. Huh. That's great. I didn't make it up. Please forgive me for I have sinned. Lying about what?
You've signed.
You have signed. No, you know. I mean, his spelling of winning was wrong. But his spelling of sinned is correct. I assume it's a him because it's boss dad. So that's just an assumption. If I'm wrong, please tell me, and I will adjust. Levi, come on up, huh? It'll be fun.
I'm so very thirsty, my lord.
Very good. All right, we're about to post on Instagram.
Can I erase this?
Is there 2 complex roots and 1 real root? Yeah, I guess that must be what they're asking. If you graph the other ones...
Can I erase it?
Yeah, they're all absolute bananas. Okay, so what's happening here is it has 1 real root, and they did not mention real or complex, which means they did not fully ask a good question. The other ones, I'm guessing, all go through the x-axis at multiple places. Oh, that is interesting. You get to click on something. Maybe they link.
It's wolfing off, yeah.
No, I know. I'm saying did they link. Oh, thank you. Let's see. Okay, now wait. Where's our mouse? This isn't the one that... Let's see, wait. What you're sending me is not... Roots. Complex roots. Oh, I guess it just doesn't touch there. Probably gets really close. Interesting. I gotta go pro. I'm not gonna go pro. Yeah, okay, that must be what they're saying is 1 real root. The rest of them probably... Oh, wait, that's wrong. Oh. You're sending us on a hunt for Wolfram Alpha. Yeah,
So
I was gonna say...
Was it nice in Hawaii?
No, it was terrible. It snowed the whole time. Oh, Hawaii.
Dude.
Oh, yeah, it was beautiful. Sorry. I thought you were talking about Chicago.
Oh, was Chicago snowy, really?
Alternate forms. Okay, wait. You can do that. You can make it... Oh, we have to know the cubic patterns, don't we? It is only 1 real root. It has no complex roots. It's a perfect cube. So you can't use factor by grouping to find a perfect cube, can you? You have to know the factoring patterns. Ah, jeez. All right. Well, hey, this is a learning experience for all of us. So you probably know the x squared minus y squared. Probably know the factoring pattern for the difference of squares, which is x plus y times x minus y. Well, from the same people who brought you the difference of squares is the difference of cubes and the sum of cubes. Let's ab minus b squared. And then if you have the sum of cubes, I believe that is a plus b, a squared minus ab plus b squared. So, who's better at math out of the two of you, out of you two? I don't know. We're both equally idiots. I don't know. I'm not gonna conjecture here. So, how do we know that the one that's right is right? We have x cubed minus 3x squared plus 3x minus 1. Okay. In the sense of being x minus 1 cubed. Oh, this is not the difference of cubes. This is not the difference of cubes. That's totally different. Wow. Wow. This is just an absolute disaster. Here's what I'm going to find. All right, cubic factoring patterns. I am so sorry. This is a learning experience for all of us. Cubic factoring patterns. Let's see what we have here. Okay, so it's not that. These things are true, but that's not what these patterns are. Factoring the sum. Levi, oh, goodbye, boss dad. It's not even, it's not this either, because what we have is a minus b cubed, which is not the difference of cubes. It's a different pattern altogether.
Sum of cubes? No, that wouldn't make sense.
Okay, first square trinomial. Yeah, but I want a cubic. They get this into trinomials. I'm gonna go to the next link. Make sure that you're entertaining them.
Look at the entertainment. Look at the entertainment. If you're not asking questions, you're doing it wrong.
Hey!
Oh,
Instagram story.
oh yes. Levi, can I spin? I'll spin.
Hey, look who's spinning.
Wow, my face is so white.
We're
Oh
streaming
my
right
gosh.
now. It's the lighting.
Hey, look who's spinning.
No, that's not
My
why.
face is so white. We're streaming right now. It's the lighting.
Okay.
Hey, look who's spinning.
That's our story.
That's perfect.
I guess we should have mentioned that we're streaming.
Yes.
Okay, we're gonna throw that on there. Wait, can we not? No, okay.
Oh, go to.
It's uploading. We're gonna need to put something more.
I'm gonna just get rid of this. Do we need this?
No, you delete
Plan
it.
man with the plan. Do you have any more questions?
Here, new story. No, that's a picture.
No.
I'm so bad at this.
Dude, a picture tells 1,000 words.
Yeah, but a video tells like a multiple of millions of words.
Well, it's many pictures, so that would mean only one word.
I don't want to use this one. Gosh. All right.
Just this one.
We're streaming.
Right now.
Come watch. It's fun. There we go. All right. Everyone's going to show up.
I'm so very tired, bro.
All right, then let's actually derive this pattern, because I'm interested. You have, okay, x minus a, and you have that cubed.
Should try to tutor while streaming Fortnite.
X squared minus 2
How?
ax plus a squared times x minus
Explain that idea. I think it's a terrible one, so I want to hear more about it.
a minus ax squared minus 2a x squared.
Do you need this, or do you need this?
Yeah. Use your nog.
Nogward?
Yeah, your nog word. Okay.
Play Fortnite, stream it. Got it so far?
Okay, we did that. Minus 2ax squared minus 2a squared.
Is that all of it?
X. Stop it.
I'm
Plus
talking to them.
a squared x.
Not you.
Stop it. I know. I don't want you to stop. Minus a cubed. And if we simplify that, let's see. We have some x squareds. We have some a squareds. Okay, x cubed minus 3ax squared minus. Now that would just be plus. Did I screw something up here?
I'm also trying to explain linear equations.
Minus 2ax squared minus 2a squared x plus ax squared plus a squared x. Okay, so this would be minus a squared x minus a cubed.
That's a good idea. If we knew how to play Fortnite, we might do that.
That'd be pretty wild.
That would be pretty wild.
If I do this right, minus 2ax plus a squared. Yeah, that's right, times another x minus a. X cubed minus a x squared. Here we go. Minus 2a x squared minus 2. That's plus. That's why. That's plus. This is plus 3. Okay. And that ends up being the pattern that we had, because we had x cubed minus 3x squared plus 3x minus 1. So that is the application of this pattern when a is 1. So this
It
is
works.
x minus 1. Ah, yes. Okay, so we have to remember that. That's annoying.
This?
No, like this is the cubic factoring pattern. If you have that, it's a perfect cube. That is a perfect. After trinomial is what? Quadrinomial.
Trinomial.
Does it just go to polynomial after that? There's got to be a four-nomial.
Polynomial.
Phrenomial.
Yeah.
Not for me. Not for him. Phrenomial.
Yes.
Charge! It's a battle. I have no idea how to recognize that. You'd let your calculator do what it did. I mean, you use Wolfram Alpha, but your calculator can do the same thing for you. And you'd find that it only has one root. Very interesting.
Ooh. 4 + 2, 8.
It's a good plan.
I like that plan. It's the best plan. All right, and if it was plus, then all of this stuff would end up being plus. I think the only difference would be this would be plus. When you think about that, that would be plus. Yeah, there'd be no minuses. It'd all be plus. Okay, so if it was x plus a cubed, you'd get down to x cubed plus 3ax squared plus 3a squared x plus a cubed. And just like the difference of squares, one of the signs you're looking for is that this is square, that's square. This is going to be a perfect cube, and that will also be a perfect cube. And if you see those things, inspect it. Maybe you got that pattern, maybe you don't. I don't know. Maybe you're spending too much time in the bathroom these days, Levi.
Yep.
I don't know. I'm just trying to make this a little less dry than it has to be. I'm mentioning
So dry.
Levi's. You got another question. I have more peanut butter, so it looks like we're good.
What's your question, Nave? Spit it out.
Yeah. You just tell us the question.
The science section isn't real.
By the way, I gained like 5 pounds.
Did you really?
Yeah.
Oh my gosh. 5?
Probably more like 4.
That's a lot of pounds, dude.
All right, I didn't gain that much. I probably gained 3 pounds.
It's a lot of pounds.
You know what? It wasn't that much.
I don't
just
care about this.
Probably gained 3 pounds. About the real science section, not the complex one.
Ooh.
I'm not sure what that means because there's only one science section on the ACT.
He's just making a real versus complex joke.
Oh, real, not the complex one. Ah, ha, ha, ha. Some of the passages are mostly graphics and charts. That's true.
Some of the passages are mostly graphics and charts.
That's not what I sound like, Levi. It's not. And I like those. Yeah, you're a good company. Most people like those. I do this in my spare time, when I have spare time. Here comes the question, though, and it's just going to knock our socks off. Question is, what do I do with the one that's not graphics and text? Yes. So there's one in particular called the conflicting viewpoints section that there's typically no graphics whatsoever.
Conflicting viewpoints.
It's scientist 1, scientist 2, scientist 3, or student 1, student 2, student 3. Yes, you probably do because everyone does. What you need to do is leave that one till the end. Always skip it when you get to it and leave it till the end because it will take you the most amount of time. What your strategy should be for that is to read, there's always an introductory paragraph that explains what's going on, and then there's all these scientists and students with their own hypotheses for why it's happening. You need to read that first paragraph about what's going on. That will give you some context, and then you're going to want to read the topic sentence for each of the scientists. Okay?
Huh? You want to do this?
You want to do one?
By you.
That one like has that chart.
That's true. I can pull up a different one.
Yeah, pull up a different one. And then you go to the questions. Now you will have to go back and forth, and you will have to go into some of the details of some of the scientists, but that gives you enough of a head start so that you know the main idea of what's going on, and then the questions you will know where to go. Because again, there's a lot of information that you're not going to need to know, and there's a lot of information that you are going to read, and it's useless. It's like, I don't even know what this means, because it's incredibly esoteric knowledge. All right, Levi's going to put a conflicting viewpoints section on the. Oh, I like the one about butterflies. You know why? Because I like butterflies. You don't like butterflies? Because there's this great science passage about them. You know, the hypothesis means under thesis. Do you know that? Yeah, you should crop the bottom. There we go. Yeah, that's good. Very good. All right. Here's how I recommend. You want to just give it a quick squirt?
Oh, there. You can do the front.
Very good, very good. In the fall, monarch butterflies in eastern North America migrate to Mexico, where they overwinter in high-altitude forests of Oyamel fir, an evergreen conifer. The butterflies accumulate body lipids.
Why are you reading that?
Because I told them to read the first paragraph.
Oh, that's what you do?
Yeah,
Okay.
yeah. First paragraph and then the topic sentences of each of the scientists.
Before doing any of the questions?
Yes.
Oh.
Yeah.
Since when did you say that?
Always.
You never told me.
I compromised because I stopped having students read everything before, with at least this passage. Where we had an argument about this, and I said, "You're right. Only the topic sentences of these." But the introductory paragraph. All right, this is what I think. Levi he can tell you what his thing is afterward. The butterflies store body lipids to use as a source of energy at a later time. Consider the following 3 hypotheses pertaining to when they're all that stuff. Okay, hypothesis 1, monarch butterflies require energy from stored lipids for migration and during the overwintering period. Done. Hypothesis 2, monarch butterflies require energy from stored lipids for migration, but not during the overwintering period. Okay, very simple difference between those two. That's why reading these intro sentences. Thank you here in the moment. I am back. And hypothesis 3, monarch butterflies require energy from stored lipids during the overwintering period, but not for migration. Okay, very simple differences for both, for migration, for overwintering. So, which hypothesis, this is number 8, if any, asserts that monarch butterflies store lipids during 2 distinct periods? We know which one that is. That's scientist 1, because it's the 2 different periods they have, which is the migration and the overwintering period. So by reading the topic sentences, we're already ready for that question. So that's it. Hypothesis 1, done. Number 9, which hypothesis, if any, asserts that monarch butterflies require energy from stored lipids neither for migration nor during the interwintering period? None of them. They all say they need it for something, for both, for migration, for overwintering. So that's none of them. Number 10, based on hypothesis 3, which of the following figures best depicts the change in the lipid mass of a monarch butterfly from the beginning of migration to the end of migration? Note in each figure, B represents the beginning of migration and E represents the end of migration. Okay, so let's remind ourselves what hypothesis 3 says. They need energy from stored lipids during the overwintering period, but not for migration. So if they're saying change in the lipid mass, lipids is what they're using for energy for overwintering, but not for migration. So they would not be using the energy during the migration itself, which means they shouldn't experience any change in lipid mass because they're not using it for energy. So my guess here is going to be G. I would also say it's going to be G. I'm just going to scan through the rest of this. The butterflies do not store lipids before they begin. Now this isn't, okay. Butterflies do not store lipids before they begin the migration. Instead, lipids are stored during migration. Therefore, lipid mass, lipids are stored during migration. Therefore, lipid mass continuously increases from the beginning of migration till the end of migration. Now, that's different. Exactly. I wasn't totally confident. My guess was that it was going to be G, but now that I'm looking at the evidence, it looks like it increases throughout the migration, so it's going to be J. Exactly.
Hey, Brady.
Yes?
I have to call a mom now. Is that okay?
No.
Prospective mom.
No. Those are not as important as this. Especially because I'm currently at the screen, so if you're gone, then I'm still here. So I guess what I'm saying is go. No, travelers. No. George just responded to our Instagram story with a little fire. Yes, our marketing is working. Okay. Number 11. Assume that changes in the body mass of a monarch butterfly are caused only by changes in the mass of the butterfly's stored lipids, which is what this whole thing's been about. The statement, the percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning of migration than at the end of migration, is supported by which of the hypotheses? So if it's greater at the beginning and then lower at the end, that means that it must have used up the energy. Thank you. It's good to see you as well. Again, I'm so interested as to why you're so adamant that we cannot say your name. Someone from YouTube just started. You don't see it on the Discord on the chat here. Okay, have you ever given us a reason why? Because no one can see. I mean, I guess people on YouTube can see, but most people are on Twitch watching. But thank you for the trip was great. My brother is now married. Hawaii is beautiful. We were in Maui in particular, and I was the one who officiated. So I was the one that was like, "Do you take her? Hey, do you take him?" And they were like, "I do, and I do," and they made out. It was awesome. No, it was a very straightforward kiss. I don't need to tell you any more about that. So which has butterflies losing energy because they're using it up during the migration? That is what this is asking. They use it for both, is what this is saying. Okay, during migration, as stored lipids are converted to energy, lipid mass continues decreases. So hypothesis 1 that agrees with that. Here we go. Butterflies store lipids before they begin their migration. As stored lipids are converted to energy, the mass decreases. Okay, so hypothesis 2 is also on board. Okay, butterflies do not store lipids as they begin their migration. Instead, it continuously increases during migration. So hypothesis 3 is out of there. I know. How'd we do? How'd we do? And again, can you tell me why you don't want us to say your name? Can you just... It's totally fine. We won't do it. I'm just so curious because you have all caps, which means like you're really serious about it. I will not say your name. I will not. I think Levi screwed it up last time. It wasn't me. But please, why? It's not even your name. It's like a funky screen name. Inside joke. So we can? Or is that just something you're always saying to us? I can't tell. Who is an inside joke with? With whom is it an inside joke? Number 12. I didn't say your name. I did not say your name. Please, who is this inside joke with? You need to give us more information. This helps a bunch. Okay, good. We were doing this for you, so hopefully you can... that's the flow of it. Levi goes straight to the questions. I wouldn't get it, Bird. I wouldn't get it. Levi, the person whose name... Oh, that's not Levi.
Oh,
No.
sorry.
That's all right. You just be Levi next time, though. I wouldn't get it. All right, so that seems to clear it up with the science section. So yeah, you want to do that last. Oh, look at that. A x squared minus 16 appeared. A rogue x squared minus 16 appeared. It's like Pokemon. I gotta catch it. Gotta use my Master Ball. Pokemon, gotta catch him. Bye, Levi. Bye, mystery person. Oh. Mystery person. Mystery is spelled with a Y. But yeah, remember to do that passage last, if you took anything from tonight. I'm at a 30. I feel kind of disappointed. That's a very good score. You broke the 30 barrier. Do not feel disappointed, especially like where did you start? I know that. Yeah, that's awesome. That's very good. Where did you start? That's really the important thing, is how much have you improved? If you had gotten a 34 before and then you just got a 30, well, that's a slightly different story. So 27. Yes, good. Yes, the schools that you can get into with a 27 and with a super score of 31 are pretty different. You have expanded the reach of possibilities for yourself by doing that. Do you plan on taking it again? Can you also can you use a different screen name that we can say? Is that cool? Annotate the science section. Here in the moment, good question. Depends what you mean by annotate. For normal passages that are just the graphs and the questions, as you're reading the question, remember, you want to skip reading the passage, go straight to the questions. As you're reading the question, and I can switch screens, yes. Okay, good, because then we can say it, because we usually want to respond to people with their name, but we don't want to screw that up, so it'll be a lot easier. if you want to underline certain parts of the question that are very important, as according to scientists, 3, bam. In figure 2, bam. Then that's fine. You don't need to write notes in the margin for any of the sections. That's a lot. You need to do that for English class, but not for the ACT. Underlining while you're reading, though, is very helpful. But you should not be reading the science passages unless you need to after you start at the questions. Questions might ask you about might be some word in there that you've never heard of, and it's like, how am I supposed to know this? Well, you're not, but in the passage they define it. So there's information you're going to need to know for this question, so you have to go look for it. But for a lot of the questions, you just go straight to the graphs and answer them based off of that.
Beep. Oh, I dropped the marker. Oh, man. Beep, bop, boop. Beep, bop, boop. Okay, you can say my screen name now. Okay. Hip Chocolate Chip. That's a chipper screen name. Hip Chocolate Chip. I like that. I feel like it's better. It's very silly, but it's very better.
Yeah. I mean, both the names are good, but having a name we can actually say is what a name is for. Otherwise, what's the point? Here in the moment. Yes. XD. That's what that face is. It's it to the side. Yep. Hip chocolate chip. That chocolate chip is hip. That chocolate chip over there, not hip, but this one, hip. This is the one I'm going to hang out with. There's 2 muffins in an oven. Roasting. One of the ovens, sorry. Jeez. 2 muffins are baking in an oven. One muffin says, geez, it's hot in here. The other muffin says, holy crap, a talking muffin. I taught that to a 6-year-old a couple days ago. He was not a fan of it. He just didn't. I think it's the theory of mind that a 6-year-old is not fully understood yet that would make a joke like that not make a lot of sense. I think I struggle with science passage. It's just so much attention to detail. Yeah. Yes and no. Yeah, I mean, yes. Yes. But again, I mean, are you going straight to the questions? Or are you trying to read everything? Because there's so much information, and that information is also just the driest stuff in the world. So that is not the way to approach it. Questions, good. Okay, yeah, I assume that. But yes, it is. It is a lot of detail. Questions point to very specific parts of graphs. Stuff like that. Yeah. All right, what time is it? What do we have here? 8:47. Oh, we're kind of getting there. We are getting there. Okay, that's fun. Okay. So here in the moment, do you want to dive into that a little bit more, or do you have specific questions about how to make it better? How to make it better? We can talk about your science sections. Okay, very good. All right, here's a fun one. Okay, there we can actually see almost the whole passage. Inside. Yeah, I'll make this smaller. Oh, it doesn't go above that. That stinks. Okay, we can make it go above. Haha. Okay. Okay, number 15. According to figure 2, which bam is right there, the solar radiation intensity. Levi is taking an important phone call. 8,000 years ago was closest to which the following. Okay, figure 2. Bam, we're looking at figure 2. Quick cursory glance at figure 2. On the x-axis, we have thousands of years ago. We have 2 different lines with a key. 2 different lines with a key. and two different y-axes because they're measuring two different things. They just happen to be measuring those two things over the same time period, which is why it's convenient to put them all on one graph, but you've got two different y-axes. Do not look at the wrong one for the wrong line. Great. Solar radiation intensity, which line is that? We have the dotted line, which is solar radiation, probably that one, and then there's methane concentration, CH4, which is not what they're asking about. We're looking at the dotted line. Okay, 8,000 years ago was closest to which of the following? So year-wise, it starts at 0 and then moves increasingly to the left. So 8 is going to be from 5, 6, 7, 8. You want to go to that 8 hash mark and go up, and then go to where it intersects with our lines. But remember, we want to look at the left y-axis, because that's solar radiation. The right y-axis is concentration of CH4. Different numbers altogether, different meaning. So at 8, it looks like it's about almost to 500. A little bit less than 500, it looks like. Was closest to which of the following? But we do have these large chunks here. We go up in terms of 5s. So I would say it looks very close to 500, a little bit closer to 500 than 495. So I would also say C. Yeah. Yeah, it's like a textbook science section question. Textbook. It's first grade, SpongeBob. Number 16, which is another according to figure 2. According to figure 2, if the trend in CH4 concentration had continued to match the trend in the solar radiation intensity, the CH4 concentration at present would most likely be what? They decoupled around 5,000 years ago. It used to be that they would match each other, and then the CH4 concentration started increasing, and the solar radiation just kept going down. So it's asking, if they had continued to match each other, where would CH4 be today? Present is on the right side here. That's where we're 0 thousands of years ago. So if the solar radiation, I'm sorry, if CH4, yes, CH4, if it had continued to match it, it would have just kept going down this line and ending up right over here, which is very close to 450. But let's get our scale right. That's 500, which makes this 475. So it's somewhere between 450 and 475, and it's a little bit more than 450. So we have less than 550, that's got to be it. It's got to be. It's not greater than 650 because that is up here. Remember, they're saying if it instead had continued to go with solar radiation. That's what they're asking here. So it did not, you wrote the solar radiation line. I did, because that's what the question's asking. If it had continued to trend, which it did not do, but if it, yeah, exactly, you got it. You got it. Good. Okay. Number 18. Number 17, sorry. Suppose that wherever the CH4 concentration increases, a corresponding immediate increase in average global temperatures occurs, and that whenever the CH4 decreases, a corresponding immediate decrease in average global temperature occurs. Based on figure 2, again, which of the following graphs best represents the plot of average global temperatures over the past 11,000 years? So what they're saying is, as methane goes up, so does the temperature. As methane goes down, so does the temperature. Methane, over the past 11,000 years, went down and then went up. So, which graph went down and then went up? B. It's the only one that does that. That's just it matches the CH4 curve as well. All right, number 18, based on figure 1. Finally, we got some figure 1 going on. The average solar radiation intensity over the past 250,000 years was close to which of the following? All right, let's look at this thing. What do we have? Thousands of years ago on the x-axis, but it goes much further into the past. We have solar radiation intensity on the left axis, which corresponds to, again, the dotted line. And then we have that last bit, which actually corresponds with figure 2. That's figure 2 is a zoom in of this last bit, which is the methane concentration, and which is the solid line. And they're asking, what is the average? You don't need to apologize. What is the average solar radiation intensity over the past 250,000 years? So solar radiation intensity goes up and down and up and down and up and down and up and down. It's kind of like a very adjustable sine wave or cosine wave where it just keeps going up and down. It oscillates. It doesn't keep the same amplitude because it goes further up and further down. But if you ask for the average value of something that goes up and down and up and down, it's the midpoint. It is the midline. So where is this thing kind of at its midline? If we're right between the ups and the downs, we're kind of along this line here. Kind of, yeah, right around that line there, which is around 480, it looks like. 480, maybe a little bit higher than 480, is where it looks like the midline is. And 480, look at that, is an answer. Your midline is the average if it goes up and down. We got 54. Okay, number 19. One solar radiation cycle is the time between I'm going to read it here, maximum in the solar radiation intensity and the next maximum in the solar radiation intensity. According to figure 1, the average length of a solar radiation cycle during the past 50,000 years was what? The time between maxima. For the bold line? Well, really they're the same. They would have the same average, but it's the midline for the solar radiation intensity, which is the dotted line, not for the bold line. Unless you're asking about question 18. Average solar radiation intensity. That is the dotted line. Now they both go up and down together, so the midline is the same for both, but you'd have to read correctly. Solar radiation intensity is on the left, not the right. Don't confuse those. Two different phenomena, two different axes that measure them. Okay, so for this one, we're looking at the maximums and how far apart they are. So there's a maximum, there's a maximum, there's a maximum, there's a maximum. How far apart are these things? Each bar, what do we got here? 1, 2, 3, 4. Each bar is 10,000 years. So we're looking at the difference between maximums. It's in the middle of a bar, and then we go one space over and two spaces over. We get one that's kind of in the middle of the bar as well. So we went 2 full bars over to get there, which would correspond to 20,000 years, which is between 15 and 25,000. Or 15 and 35, yeah. If it's around 25, it's between 15 and 35. Lastly, which of the following statements best describes the primary effect of CH4 on Earth's climate? Okay, this is kind of a previous science knowledge-y question. Let's go through these. So we know from the passage that as CH4 increases, the temperature of the climate increases as well. So there's a positive loop, or there's a positive effect it has. CH4 gives off visible light to space, cooling Earth's climate. That's the opposite. It warms Earth's climate. We don't even need to think about the whole is it giving off light situation, which it's not, but either way, it warms Earth's climate, so that's out of there. Let's just look at the rest of them in terms of that last part of the answers. So G says it warms Earth's climate. Okay, we're going to keep it around. H says it cools it. That's out. J says it warms it. So either G or J. The specific reasons. CH4 gives off ultraviolet radiation to space, warming Earth's climate. If you give off radiation so it goes away, you're losing energy. So that would be not exactly the best way to keep something warm. And J, it absorbs heat that comes up from Earth's surface, warming Earth's climate. If it absorbs heat, it keeps it in. So as opposed to this light bouncing off of Earth and then bouncing back into space, it now is absorbed by the methane. So it stays in the atmosphere, which is what keeps the climate warm. CH4 does not give off ultraviolet radiation. That's like light. It gives off ultraviolet light. It's just a gas. It doesn't do that. The sun gives off light, but the gas traps it by absorbing it into the climate, warming it up, making the polar bears go bye-bye. That is, there's a science passage for you here in the moment. So yeah, you have to be careful. Whenever it asks you to look at a graph, give the graph a quick glance. What do we have on this graph? X-axis, Y-axis. What's the trend? Is there a key? Investigate that key. Tear that key apart. Figure out what it's telling us. Don't let it get away with anything. Be good practice. I agree. If there's anything else, let us know, or let me know, because we have 3 minutes. If nobody has any questions, I might just call it. The last passage. No. The science section does not get progressively harder. Every passage has a mixture of easy and hard questions. Beep, beep, ba. Beep, beep, ba. 1, 2. That's the old 1, 2 right there. A little bit of 1, 2. And you give it a little bit of 3, 4, which is another one. I think. 1, 2. A jab, an uppercut, a haircut, and then you're good. That's how boxing works, from what I understand. You got to get a haircut while you're boxing, during the match itself. I feel like boxing used to be a lot more popular than it is today. But maybe it's always been kind of, that's a good night. Very good. All right, you've been the only one asking questions, so I will give 5 more seconds to anyone who wants to ask a question. Otherwise, I'm going to be gone. All right. I'm going to be gone.